Hello, my dear children. In the previous class, we have discussed some questions in exercise 5.3. Okay, my dear children, we continue the exercise. Now, in the exercise 5.3, page number 169, page number 169 in the textbook, question number 6. Question number 6. I am explaining here question number 6 because question number 4, question number 5 are also of the same type. So you try the question number 4 and question number 5 after seeing the solution of this question number 6. Okay, my dear children, after watching the solution to this question number 6, you try the question number 4 and question number 5. The two questions are also same that of question number 6. That is why I am explaining question number 6. Okay, my dear children, right. Find dy by dx if x cube plus x square y plus xy square plus y cube is equal to 81. Here we have to find dy by dx if this condition is satisfied. If this given, if the condition or if the relation between x and y are given in the form of in this equation. Okay, my dear children, if we observe this function, it is an implicit function. It means we can't write this function as y is equal to f of x. It is a implicit function. Okay, my dear children. So let us take the given equation as it is. I wrote here x cube plus x square y plus xy square plus y cube is equal to 81. Now I am differentiating with respect to x. Previously I told you this is the short form of the sentence differentiating with respect to x. Then what is the differential operator? D by dx. So I wrote here d by dx in LHS as well as in RHS. D by dx of the given function x cube plus x square y plus xy square plus y cube is equal to d by dx of 81. Understood this step, my dear children? Right. Now come to LHS. There are 1, 2, 3, 4 terms are there. 4 terms. So we can find the derivative of these 4 terms separately. That is why I am writing here d by dx of x cube plus d by dx of x square y plus d by dx of xy square plus d by dx of y cube. Understood this LHS part, my dear children? Right. That is equal to 0 because here this is a constant term. D by dx of constant is equal to 0. We used this formula in RHS. That is why I wrote here 0. Understood the part in RHS, my dear children? Right. Now come to LHS. In the next step, first term d by dx of x cube. It is in the form of x power n. D by dx of x power n is equal to n into x power n minus 1. We use that formula for the first term. To find the derivative of this first term, we are using d by dx of x power n. Understood, my dear children? So here n means 3. 3 into x power 3 minus 1. What will you get here? 2. So 3x square. So differentiation of the first term is over. Understood, my dear children? Now come to the second term. D by dx of x square y. D by dx of x square y. It is in the form of d by dx of f of x into g of x, or it is in the form of d by dx of uv. Here we have to use uv rule, that is product rule. Understood, my dear children? Because x square is variable, y is also variable. So here we have to use the formula d by dx of f of x into g of x. So f of x means here x square and g of x means y. So f of x we write here x square into d by dx of g of x in your mind. Okay, imagine this is f of x and this is g of x. We have to imagine it. So f of x into d by dx of g of x plus g of x into d by dx of f of x. Understood these two terms, my dear children? Right. Plus again here also this is a variable, y square is also a variable. So here also we have to use the same d by dx of u by uv formula, product rule. Okay, my dear children? So here f of x means x and g of x means y square. So f of x into d by dx of g of x plus g of x into d by dx of f of x. Understood these two terms, my dear children? Right. Now we are finding the derivative of this last term, d by dx of y cube. It is in the form of d by dx of x power n. In the place of x, y is there. Okay, my dear children. So here we use chain rule. Okay, because we are differentiating with respect to x, but here variable is y. So in your mind we are assuming that this is x in your mind. So 3 into x power n formula, n into x power n minus 1. So 3 into y power 3 minus 1. What will you get here? 2. So 3y square into d by dx of y. We are using here chain rule. Understood this term, my dear children? Right, is equal to 0. Understood this equation, my dear children? Right. Right. So for the previous step we use this formula, d by dx of f of x into g of x. D by dx of f of x into g of x is equal to f of x into d by dx of g of x plus g of x into d by dx of f of x, and chain rule. We used all these formulae. Okay, my dear children? Right. Next we write, first term we write as it is 3x square plus x square into d by dx of y means we get dy by dx plus y into d by dx of x square. What do you get? 2x. Here x power n formula, d by dx of x power n formula plus x into here d by dx of y square. What do you get? 2y. D by dx of x power n formula here also. So and chain rule. So y square derivative 2y into d by dx of y. Okay, my children? Plus y square into here d by dx of x 1. Understood this term, my dear children? Plus 3y square into d by dx of y means dy by dx. Understood all these terms, my dear children? Right. Because dy by dx of y is equal to dy by dx. D by dx of x power n is equal to n into x power n minus 1. And we used chain rule also. Understood, my dear children? Right. So after this step I am writing this step. First term this as it is 3x square plus x square into dy by dx plus y into 2x. We can write this term as 2xy. Okay, my dear children? Plus how do you write this term? 2xy into d by dx of y means dy by dx. Previously we wrote that formula, d by dx of y means dy by dx plus y square into 1. What will you get here? Y square plus 3y square into dy by dx is equal to 0. Understood all these terms in LHS, my dear children? Right. Now we are separating all the terms which are having dy by dx and all the terms which are not having dy by dx. See, in this first term, is there dy by dx? There is no dy by dx. In the second term, there is dy by dx. In the third term, there is no dy by dx. In the fourth term, there is dy by dx. In the fifth term, there is no dy by dx. In the sixth term, dy by dx is there. So by taking out the common factor dy by dx, we get here x square plus 2xy plus 3y square. These three terms, from these three terms, this second term, the fourth term, and from the sixth term, we are taking out the common factor dy by dx. Then we get these three terms in the brackets. Understood this part, my dear children? Right. Now we are transposing the remaining terms which are not having dy by dx to LHS. We are moving the terms. So plus 3x square becomes minus 3x square, plus 2xy becomes minus 2xy, plus y square becomes minus y square. I directly took the common factor minus 1. Then minus of 3x square plus 2xy plus y square. Understood this part in RHS, my dear children? Right. Now we are finding dy by dx. This implies dy by dx is equal to minus of 3x square plus 2xy plus y square whole divided by, we write this function, that is x square plus 2xy plus 3y square. This is the value of dy by dx. Understood, my dear children? Right. Similarly, you try the questions, question number 4 and question number 5. Same that of this question. Okay, my dear children. Will you try the questions? Can you do the sums for question number 4 and question number 5, my dear children? Right. Now come to the question number 7. You try the question number 8. The question number 8 is also same that of question number 7. So here I am explaining the solution to the question number 7. Okay, my dear children. Will you try the question number 8? Can you do the question number 8, my dear children? Right. See here question number 7. Find dy by dx if sin square y plus cos xy is equal to pi. Okay, my dear children, here we have to find dy by dx. If this relation between x and y is satisfied. Here also, if you observe, this is a implicit function. It means we cannot find this equation as y is equal to f of x. Okay, my dear children? Okay. Now come to the solution part. Let us write the given equation as it is. Sin square y plus cos xy is equal to pi. Okay, my dear children. Now differentiating with respect to x. Differentiating with respect to x. Then what is the differential operator? D by dx. Remember this point, my dear children. Keep this point, my dear children. Right. So we are writing here differential operator on both sides. D by dx is the differential operator here because we are differentiating the function with respect to x. Okay, my dear children? Right. So d by dx of sin square y plus cos xy is equal to d by dx of pi. Understood this step, my dear children? Right. Now observe this LHS. In LHS there are two terms. So we have to find the d by dx of these two terms. In that case, we can find the derivatives of the two terms separately. That is why I am writing this step, d by dx of sin square y plus d by dx of cos xy. Understood these two terms in LHS, my dear children? Right. Is equal to, in RHS, d by dx of pi is there. There is no variable. Means it is a constant. It is a constant. So d by dx of constant is 0. We used this formula, d by dx of constant is equal to 0. Understood the part in RHS, my dear children? Right. Now again come to the LHS. This implies d by dx of sin square y. This is the first term. We have to find the derivative of this first term. If you observe, it is in the form of x power n. It is in the form of x power n. Here x means sin y, n means 2. Okay, my dear children, compare this function with x power n. Here x means sin y and n means 2. So we use that formula for the first term, d by dx of x power n. So n into x power n minus 1. So 2 into sin power n minus 1. 2 minus 1. What you get here? 1 only. So I am not writing 1. 2 sin y. Understood this part, my dear children? Into d by dx of sin y, because it is y. It is a function in y. We are using here chain rule. Remember this point, my dear children? Understood this part also? Right. Now come to the second term. We are finding derivative of the second term. D by dx of cos xy. Here also we use the chain rule, because here xy is there, not xy is there. That is why we use chain rule for the second term also. So consider this xy as x in your mind. Okay, my children. So d by dx of cos x means minus sin x. So minus sin xy, not x. Here we we considered xy as x in your mind. So minus sin xy into d by dx of xy. Whatever the function we assumed as x, we have to take the derivative of that function. Understood this part also, my dear children? Right. That is equal to 0. Understood this step, my dear children? In this step, I used this formula d by dx of x power n is equal to n into x power n minus 1 formula, d by dx of cos x is equal to minus sin x formula, and also chain rule. Okay, my dear children? Understood? Right. So after this step, let us take this step. 2 sin y into d by dx of sin y is there. Here also we have to use the chain rule, because it is a function in y, but we are differentiating with respect to x. That is why we consider this y as x in our mind. Remember this, my dear children. So d by dx of sin x is equal to cos x. So cos x means here y only. We are using chain rule. So into d by dx of y, because we assumed here y as x in our mind. We used here chain rule. Okay, my dear children, understood this part, my dear children? Right. Next term, minus sin xy into d by dx of xy is there. Here x is a variable and y is also variable. So here we have to use the formula d by dx of f of x into g of x. Consider this function is f of x and this function is g of x, because both are variables. Okay, my dear children? So minus sin xy into first function f of x into d by dx of g of x means y, plus g of x into d by dx of f of x means x. Understood these two terms, my dear children? Right, is equal to 0. So in this step, I used this formula d by dx of sin x is equal to cos x, and d by dx of f of x into g of x is equal to f of x into d by dx of g of x plus g of x into d by dx of f of x, and also chain rule. Understood, my dear children? Right. Now come to the next step. This implies in this first term 2 sin y cos y into d by dx of y is there. What is d by dx of y? dy by dx only. So understood this first term, my dear children? Right. Now come to the second term, minus sin xy into x into d by dx of y means dy by dx plus y into d by dx of x is equal to 1. Understood this step, my dear children? Right, is equal to 0. Understood this terms in LHS, my dear children? Right. So here I used this formula d by dx of y is equal to dy by dx, and d by dx of x is equal to 1. Understood this step, my dear children? Right. After this step, let us write this step. This implies we write this first term as it is 2 sin y cos y dy by dx. Okay, my dear children? Now come to the second term. Here we are using the distributive property. You have already learnt what is meant by distributive property. We have to multiply each and every term by this term. So what you get here? Minus x sin xy dy by dx minus sin xy dy by dx minus y sin xy is equal to 0. Understood, my dear children? Right. Now, understood these two terms, my dear children. Guess we have used the distributive property here. Right. Now, from these two terms, we are taking the common factor, that is x dy by dx. dy by dx. We are taking out the common factor dy by dx. Then we get 2 sin y cos y minus x sin y. From these two terms, we are taking out the common factor dy by dx. Then we get these two terms in brackets. Understood this part, my dear children? Right. Is equal to, we are sending the term which is not having dy by dx to RHS. This is only the term not having dy by dx. So we are moving the term to RHS. So it becomes y sin xy. Understood, my dear children? Right. Now we have to find dy by dx. So dy by dx is equal to, just we send this part to RHS, then it becomes y sin xy whole divided by 2 sin y cos y minus x sin y. This is the value of dy by dx. Understood, my dear children? Right. Similarly, you try the remaining questions. Eighth question. You try the remaining next eighth question, same as that of question number 7. Will you try the question number 8, my dear children? Right. Now come to the question number 9. From here onwards, the functions are inverse trigonometric functions. Here inverse trigonometric functions will be given. In that case, we have to find dy by dx. Okay, my dear children? Find dy by dx if y is equal to sin inverse of 2x by 1 plus x square. Okay, my dear children? So here, first of all, we have to recollect the previous knowledge. We have to write the given inverse trigonometric functions in a simplest form by using a suitable substitution. By suitable substitution, we have to write the given inverse trigonometric functions in the simplest form. First, we have to do that part. After that only, we find the derivative of the function. Understood, my dear children? Right. So, given y is equal to sin inverse of 2x by 1 plus x square. So, put x is equal to tan theta. By implies theta is equal to tan inverse x. This is a suitable formula, because if we write here tan theta, we get a trigonometric identity. That is why we are taking x is equal to tan theta here. Okay, my dear children? Recollect. Bring that previous knowledge into your mind. So y is equal to sin inverse of 2 tan theta by 1 plus tan square theta, because x is taken as tan theta. Understood this step, my dear children? Right. This implies y is equal to sin inverse of sin 2 theta. This is the formula for sin 2a. Sin 2a is equal to 2 tan a by 1 plus tan square a. So we wrote here sin 2 theta. Understood this step, my dear children? Right. This implies y is equal to 2 theta. Sin inverse and sin function gets cancelled. Then we get 2 theta, because sin inverse of sin x is equal to x. This is also one of the properties of inverse trigonometric functions. Okay, my dear children? This implies, understood this step, my dear children? Right. This implies y is equal to 2 into theta. What is theta here? Tan inverse x. So, first we have simplified. We have written the given inverse trigonometric functions in the simplest form. Then we start the differentiation part. Okay, my dear children? Right. So here we got y is equal to tan inverse x. After writing the given inverse trigonometric functions in the simplest form, finally we got this equation. Then we take differentiation, differentiating with respect to x. Okay, my dear children? This implies d by dx of y in LHS, d by dx of y is equal to, in RHS, d by dx of 2 tan inverse x. Here I wrote the differential operator d by dx on both sides. Okay, my dear children, understood this step? Right. This implies d by dx of y means dy by dx is equal to, here 2 is a numerical coefficient. We can write it outside the dy by dx. So we write here 2 into d by dx of tan inverse x. Here because d by dx of y is equal to dy by dx. Understood this step, my dear children? Right. This implies dy by dx is equal to 2 into d by dx of tan inverse x. You know the formula, d by dx of tan inverse x is equal to 1 by 1 plus x square. That is why I wrote here d by dx of tan inverse x is equal to 1 by 1 plus x square. Understood this part, my dear children, in RHS? Right. This implies dy by dx is equal to 2 into 1 by 1 plus x square. What do you get here? 2 by 1 plus x square. So this is the value of dy by dx. Okay, my dear children. The remaining questions, question number 10, question number 11, question number 12, question number 13, question number 14 and question number 15. All these are inverse trigonometric functions. For all these questions, for finding the dy by dx, first of all we have to write the given inverse trigonometric functions in its simplest form, like this. We have to write the given inverse trigonometric functions in the simplest form. After that we have to find the differentiation. Okay, my dear children, will you try the remaining questions? Question number 10, question number 11, question number 12, question number 13, question number 14, question number 15. We have to find out the suitable trigonometric functions to get a trigonometric identity. Okay, my dear children, will you do the remaining questions in this exercise? Right.